איזשהו יחס מסוים בין A ל-B כדי שזה ימשיך לצאת בצורה מסודרת למדה?
That depends on the function. It's like a...
נגיד אם אני יודע שנגיד יש לי 5 ב-A ו-2 ב-B אז אני מקבל נגיד למדה, אז צריך להקפיד אחת שלי A יהיה 10 ו-B נגיד יהיה 8 או משהו כזה, מה שדברים יסתדרו, כאילו יותר להגדיל פי אותו מספר את A ואת B או דברים מסוימים שלי.
Yeah, like that's not going to work for any value of A and B. The specific value of A and B, that's like relation between A and B. That's
אבל אני צריך לדעת מה היחס בין, אנחנו יכולים לדעת מה? או שזה different?
That's depend on what we're going to the question that we're going to ask. Like we can start from like no A and B and get like other stuff from that, or we can like find A and B from other assumption. Okay, the recording is loud, so we can continue. So this is a general the generalization of the homogeneous function, and okay, so for given values of A and B, this is going to be true for any value of lambda, right? Lambda can be from like 0 to infinity or whatever. So let's choose, just for fun, lambda equal to y to the power of minus 1 over b. We can. So what happens if we choose that value? We get f of y minus a over b multiplied by x, and instead of lambda to be y, we just get 1. And this is equal to y minus 1 over b f of x and y. Which means that I can write f of x and y. I just move y to the other side as y 1 over b f of y minus a over b multiplied by x. So we started from function of 2 variables and we moved to function, so this is 1. So and we ended up with function of 1 variable, which is that. Like we still have the multiplication of right outside, like it's not magic, but the dependence in the function, the argument of the function is just 1 variable. So why is that useful? If we assume that the free energy that we talked about so much in the last few classes is homogeneous function, and the reason why we can assume that I'm not going to talk about, we can say that for G, which is the free energy of T and H, which is reduced temperature and magnetic field, this is equal to, for example, T to the power 1 over B, G of T minus A over B, H1. I didn't say anything yet about the values of A and B. So that means that I have now a function of something that depends both on the temperature and the magnetic field, which is kind of what I wanted to begin with. So usually in like literature and probably in the lecture and stuff, that parameter like A over B is called delta, and like delta have like different values for different systems. Like we're not going to go too much into that, and also the value of B is going to depend on the system. But in general, this is like a type of relation that we can write. So let's take for example like some form of the free energy that we used in the last few classes. So we have A of T. You remember the parameter, the change sign when we before and after the critical temperature, m squared plus b, m to the power 4 minus h m. So if we find the critical exponents from from that free energy, we get that m go to be, we use like m go to as t to beta, and h to 1 over delta, so we get the delta is equal 3 and beta equal half. And if you write the free energy around the critical point, which is around, like using either in the limit where h equals 0 or t equals 0, which is mean either that or that, so that's for t equals 0, that's for h equals 0.
זה main function של הפחם?
Not main function, free energy.
Free energy.
Yeah, this is like the kind of the general form that we usually take, but it can be also something else. Like we're going to use other stuff. This is just an example. So we're going to solve soon like a more organized question, but just to show why we chose like that specific way. So if we take h equals 0, for example, so we get that the free energy scale with the temperature like T square, because this scale is like T, and m square scale like T because of that relation. And if we take T equals 0, so we look only at the dependence on the magnetic field, we get that the free energy go like h to the power of 4 over 3, right? Because we have m to the power 4 and delta equals 3. So we can either look at the free energy at the t direction, at the t axis, or the h axis. So this is like two limits. So if you look at the expression that we got here, we can take, for example, h go to 0, and then I'll write it here. So for h equals 0, g of t 0 is t to 1 over beta. G, so now I have h multiplied by some dependent of t, so all of that is going to be 0. So this is 0 and 1. So I got rid of the dependence on the temperature inside the argument of g, so this is just going to be some constant, like some number. And the only dependence on the temperature is going to come from this. So the free energy scale like t to 1 over b, and we know that the free energy also scales like t squared, so in that case, b equal half. So this is just the connection between what we did last time, if we look at like each one of those separately, to that relation.
איך קיבלנו פה את הביטוי של מה עשינו פה כדי לקבל?
So I took that, and I say if I take h equals 0, so this stays the same, and in this argument I have h that multiplies some fraction of t. So no matter what's that, if that's 0, all of that's 0.
אוקיי, ואז כאילו שזה קבוע לצורך העניין, כי זה איך בנקודה ספציפית.
Yeah, because it doesn't depend on anything.
אוקיי, וזה באמת אנחנו בעצם התנהגות שהיא לא על אחד מהקווים האלה?
No, it's on that line. It's on h equals 0. Because I took h equals 0. So I just compare. So I have function that work in like all of this two-dimensional space, and to obtain those parameters, I check once that case, and I can check now also that case. I'm not going to do it, but we can check that case, and then like get like the rest of the parameters. This is basically what you're supposed to do with Python. So then you can get like the specific values of the parameters.
אבל זה היה שני ממדים, זה לא שלושה ממדים, זה עוד עניין.
Yeah, we look at two limits.
ואנחנו השפנו גם את C להיות 0, גם כן, נכון? על הסיר של H שווה. נכון?
Yeah. Okay, so this is all very general and nice. So let's solve the question. So this is from 2015. I didn't write the question, but there's 3 questions in the test. I'm sure you'll find it. So given the following scaling relation, so G of T and H is equal to X minus C, G of X A multiplied by T, and X B multiplied by H. So,
what is the question?
I will say it right now.
Ah.
So this is given, and the question is to prove the scaling relation. So we need to prove that gamma is equal to beta delta minus 1. So let's just remind ourselves. So we know that M go to T beta, H1 over delta, this is what we wrote, and gamma is the critical exponent of the susceptibility. T minus gamma.
איך מצאת את האימים של הקומולטיב? או שזה נתון?
Those are the critical exponents. They're always that's how the critical exponents defined in the universe.
Oh.
Okay? That's always true. And for those critical exponents, we want to prove that. From it. Okay. So basically what we are going to do, we are going to find each one of those exponents as functions of A, B, and C, and then compare them and see that it follows that scaling relation. So let's start with beta because it's usually the easiest. So we know that the magnetization is equal to the derivative of the free energy with the field, the magnetic field, and we either take H to be 0 or T equals 0, depends if we want to get delta or beta. So let's start with H equals 0. So what we basically supposed to do is to take the derivative of that, but we want to use A, B, and C, so we're going to take the right-hand side of the equation. So this is equal to D over H of X minus C, G of X and T. Okay, so the function that we have does not depend specifically on H, but it does depend on X beta X2 to be multiplied by H. So we can just rewrite it as like derivative by parts. So first let's take X to minus C outside of the derivative because it does not depend on H. So we have X minus, write it down. So X minus C. And then the H of X B H, and then D X B H G X A T X B H. So the first derivative is easy, it's just going to give us X to B, right? The second derivative, we don't know explicitly what G is, but we do know that the derivative of the free energy by the field term give us the magnetization. So here we couldn't, like, we had extra terms in the way, so we couldn't do it, but this is basically like take the magnetization of x, b, t and x, b, h. So there is like a, I don't know, it's called
Functional equation?
what?
Functional equation?
Sure, but not what I was looking for, but also that. If you take a derivative of a homogeneous function, you're also going to get homogeneous function.
שני מחזקת B שם בתוך ה-N?
No, that's a mistake. Yes. So if you take derivative of homogeneous function, you're also going to get homogeneous function. So we started by homogeneous function, which is the free energy, and now we got homogeneous function, which is the magnetization. So from what we got here, m of t and h is equal to x minus c plus b, m of x b t, a t x b h. So just got similar relation, but for the magnetization. So why is that used?
את יכולה להסביר רק למה יש לך שתי נגזרות, וזה נגזרת פנימית?
No, it's derivative by part. It's like if I have d dx, I can rewrite it as dy dx d dy.
Okay.
So I just multiply and divide by the derivative. That's all. So I can use that.
ואיך את ידעת שזה M?
So in general, we know that the derivative of the free energy by the field is going to give me the magnetization. So if I look at all of that, this is not exactly the derivative by the magnetic field because that and that is a different argument. But when I wrote it like that, this is like taking the magnetization with respect to that argument. So instead of the field, I have the field multiplied by something. But I just need to be consistent with what the argument is.
X is a random variable or?
X is like lambda that we had in the beginning. So X can be like anything. And now we're going to choose specific X to solve the thing.
אז בעצם אתה בעצם עושה את המגנטיזציה של המשתנה x בחזקת BA, לפי x בחזקת BH, כאילו ש-x בחזקת BH הוא כאילו ה-h החדש שלך.
Exactly. Okay, so we all agree with that. Okay, so why is that good for? What's that good for? So as I said, x is like the lambda that we introduced at the beginning of the homogeneous function discussion, so we can choose it to be whatever we want. So let's choose it to be. So we can either take x to be dependent on t or on h, and then get rid of one of those arguments. And the way we know to choose which one of them we want to get rid of is by what we want to find. So here we want to find the dependence on the temperature. So we want to have something that depends on the temperature outside of the magnetization. So let's choose x to be t minus 1 over a. And if we plug it into that equation, we get that m is equal to t c over a minus b over a, m of 1 t minus b over a h.
זה סוג של ניחוש פתרון, X שווה ל-T מינוס.
Yeah, I guess the value for I could also like choose whatever I want, but I want to choose something that's going to help me solve the problem.
And why you use it? Because you want לחלק לצמצם את הכיוון.
Yeah, so I want to reduce one of those, and as I said, the way I know to choose which one of them I want to make one is because I want to get something that's eventually dependent on the temperature. So I want something that here I want to to be left with something that depends on the temperature, because you're going to see that this is going to give me a constant in a second. Okay. So similar to what we did before, you remember we need to take h equals 0. I didn't keep it pretty well, but because we want to get the dependence on t. So now if we take h equals 0, we get that m is equal to t c over a minus b over a, m of 1 and 0. Because we have again h multiplied by something, so this is going to give us 0. Whatever I have here is just a constant. So we got that overall m proportional to t c over a minus b over a. So we compare it to the norm exponent. So beta is equal to c minus b over a. So this is critical exponent 1.
n1,0 זה קבוע כי אין שם משתנים?
Yeah, I don't have anything that can change the value, like I don't have h or t. Okay, is that one clear? Because the next two are going to be very similar. So.
אז אתה אפשר למצוא את הלמדה?
Yeah, now we're going to find delta and gamma in like a similar way, and then just going to.
ולעבוד שהם שווים?
Yeah.
זאת אומרת, לדעת מ-H יש עבור 0 כדי שתקבלי את הטמפרטורה, ואז כאילו דעת לגרום לכך שבעצם ילך גורם אחד שיתאפס וכל זה, ובגלל זה כאן תקטיר את זה.
Okay, can I erase? No. Okay, so now we want to find delta, so we don't have to do like everything all over again. The only thing that's going to change is now instead of take h equals 0, we're going to need to take t equals 0. So I'm going only to erase like the last one. So the equation for the homogeneous equation, I don't know how it's called, for the magnetization, it's still the same equation. What's going to change is how we choose the value of x. So if earlier we wanted something that depends on the temperature, now we want something that depends on the field. So now we're going to choose x equal to h1 over b. Which is going to give us h
maybe minus
c plus over b.
you don't want to choose. Yeah. You don't want to choose to the minus one for this?
Okay, so this is exactly the same. Now we're going to take t equals 0, which will bring us to m equal h c minus b b m of 0, 1. Which is also a constant. Which brings us to m proportional to h c minus b over b.
מאיפה מתחיל השינוי?
From here. Like that equation is just, I just simplified like that,
Okay.
When I decide how am I going to choose x, then it's dependent on the parameter that I want to find. So just notice that this is like it's defined as 1 over delta and not delta. So delta going to be equal to b over c minus b.
למה בהתחלה זה היה m1 עכשיו 0
Because earlier this was 1 because I chose x that depends on t, so it was 1 and 0 because h was 0, and now I chose like something that's going to reduce that to 1 and I took t equals 0, so this is 0.
כן, אבל יש משמעות לזה שזה...
Yeah, it's a different constant, but I don't care which constant it is. I only care about the dependence. Okay, more questions? Okay. So the last one is the susceptibility. So now I need to erase that, but we're still going to use that, so I'm going to leave it. So susceptibility is defined as the second derivative of the free energy. So we know, or in other words, actually, the first derivative of the magnetization. So we can use the formula that we find for m, so we won't have to do like the derivative by parts twice. So this is equal to the derivative of x b minus c m x a t h. So I just use that. So we're going to do the same as we did for the free energy. We're going to do like derivative by parts, which is going to give us x b minus c, and then derivative of that by h, going to give us another b. So this is x 2b minus c d b h of m I took derivative of like d instead of dh of that m. I say this is h dm. Similar to before. So that and that's going to give me xp, which I had.
הגורם הראשון זה
This is because it went from bit. So what's the derivative of m by the argument that is like now going to be the new field? Susceptibility for x a t x b h. So the second derivative is also going to be a homogeneous function, follows x of t and h is equal to x. Yeah, this is like 3 and this is x, right? This is 2b minus c, x of x t, x b. Exactly. So the critical exponent here is also correspond to the temperature. So we're going to take the field to 0. So we're going to choose. We need to choose. We should choose x as something that depends on temperature. So similar to before, this is t minus 1 to the power minus 1 over a. So this gives us x equal to the susceptibility equal to t minus 2b over a plus c over a, b of 1 t minus b over a, h. And now we take h equal to 0, so this is t c over a minus 2b over a. And again, this is a constant, so we're left with the dependence on t. So overall, the susceptibility is proportional to t c minus 2b over a. So critical exponent. Again, this is minus, so gamma is equal to 2b minus c over a.
איך כל להראות איך עוד לא קיבלת x בחזקת 2 b פחות c? אני פשוט לא רואה...
From this?
Yes.
So, okay, so I can take out the x part, right? That. This is equal to x b minus c d h and this is one. Now this one is equal to dth of xdh multiplied by d of xdh and it's like I divide and multiply by that. What's that?
אוקיי, x b.
Okay?
ופה מה שבכחול זה, כן, זה בגלל הזהות, כאילו למה זה שווה לנגזרת לוג'ית, כמו... לא, יותר למעלה, שורה, כן.
Oh, why that's equal to that? So that's the same thing we did with the magnetization. Like, if the susceptibility is, I'll use another marker so it works. The susceptibility equal to for t and h equal to d dh of m of t h. So the susceptibility of xat and xdh equal to d dxdh, because it have to be the same variable, of m xab t xdh.
זה הגדרה פשוט. הגדרה.
Yeah, it's just because if I didn't have this here, I had just d over dh, I had something missing, so I have to.
פשוט השלכה כדי שהכל יסתדר באותו אופן.
Yes. That's fine. Can I erase it?
כן, נו.
רגע, אפשר לעשות את השירות האחרון בבקשה, לפני שנוחות את זה? כאילו זה בסדר, זה לא כל הזמן מה שכתוב.
which
רק שני השורות האחרונות שרשמת.
so here I had
אני יכול להפריע לך, היה סטטיסטיות של 1.t בפסקת מינוס b חלקי a כפול h, ב-h שווה 0, שזה צריך להיות שווה לדבר הזה.
okay, so you understood how we got to this one?
וזה כי הצבת את בטח את הערך של ה...
Yeah, I choose x to be t...
לפני אולי. אוקיי, הצבת את זה מלפני אחד.
Yeah, so from here to here,
אז כן.
so I took h equals 0, so this is 0, and that's it, that's the only change I did from here to here.
אוקיי. כאילו את זה גם לפני כן אבל אנחנו ש-h שווה 0.
Yeah, but we didn't like it because I wanted to do that step first.
Okay.
I could do it first, but then I wouldn't get something that I can use because I will if I did it here I would still have like something of like t and 0, and that's I don't know what that is. So I wanted to get rid of the part in the argument that
לא,
depends.
אני לא בא לחלק את ה-t לצורך העניין. אם t הוא מספר, הוא לא 0, הוא רק שהוא 0. יכולה לחלק את זה, 0 תחום מספר.
Yeah, but if I want to, if I get something that look like t to something and then susceptibility of t and 0, that depends on t. I don't know what that is. I cannot say that the function is on that. I want to know how the function depends on t. I cannot ignore that. To ignore that, I need to do this.
אולי פשוט כסרון מעשי ועד שאנחנו מחשבים את הביטוי המדויק כדי שלא נקבל איזה פונקציה מסוימת אחרת, כאילו, זה נכנס שלנו.
No, like this is just as right as that. It's just a different way to write it.
כן, כאילו אחרי שאת מציבה לצורך העניין.
Because I still have stuff here. I just want to write it in a way that will help me to solve.
כן, פשוט, אז מה, בוא נסדר את הפונקציה ואז נציב, כאילו מותר לי לסדר את הפונקציה, אבל כשאני מציב אז בוא נתדע.
תרגיל שאלה מהירה. בסרט השיעור חילקת את האם פרופורציונלי ל-t בחזקת b, זה h בחזקת 1 חלקי למדה. עכשיו רשם שזה t קטן מ-0, פרופורציונלי ל-t בחזקת בטא, שווה ל-0, פרופורציונלי ל-h בחזקת. אבל פה את לא חילקת עיקרון לפי t קטן מ-0, t שווה ל-0.
Right, because so what happened is that, as I said, we look very close to the critical transition. So they're both very close to t equals 0 and to h equals 0. And we play around that point.
אבל צריך להגיד את זה? צריך להגיד את זה? כאילו, בסופו של דבר?
No, but that's the point. Like this function is going to, like, if I have like that, I have this 2D space, and I want to look around the critical point. So this function going to give me something that describes all of that two-dimensional space. And to find those critical exponents, those values, I look either here or here. I can always do that. I have a function of x and y. I can look once on x and once on y. It doesn't mean that, you know, when I say that this is for t smaller than 0 and this is for t equal to 0, so that's why I took t equals 0 when I found that, but I didn't took t equals 0 when I found that.
Okay.
So we found all of the exponents that we needed to find, and now we're just going to plug it into that equation and see if it works. So let's do the right hand side. So beta multiplied by delta minus 1 is equal to c minus b over a, and then b over c minus b. So if that's minus 1, I can write this is minus c plus b, right? Which is also c minus b over a 2b minus C over C minus B. D is going to cancel that. So this is overall equal to 2B minus C over A, which happen to be equal to the gamma. So, surprise, surprise. So, that was the question. Yeah.
בגלל שציינת אותו של H ו-E, אומרת המגניזציה הכללית תהיה משהו כפול T בחזקת בטא, פלוס משהו אחר H בחזקת דלתא, בכל נקודה אחרת בגרף.
It's not necessarily that plus that. We have some. We have some function of both variables, and then like we say that it's going to that zero and it's going to that. But we don't say what it is.
בנקודה שנמצאת בין ה-T ל-H בגרף שסרטט שם.
Here?
נניח, סתם נקודה שנבחר במצב הזה. איך היא מתוארת במגנטיזציה שלה?
So it's going to be described by, like, we cannot write explicit exponents.
Okay.
We have to get it from here. So what you can do is we got like homogeneous equation thing as similar to that for the magnetization, right? You just had like a B here. So you had we had that. So you can use that to find how M depends on like both T and H. Like you just to play with those. So we look at like specific, like the specific case of either T equals 0 or H equals 0, but you can take something in between. So basically that was the question. Just super quick. If you remember last class when we had a question that we needed to find the critical exponent, and we moved from like, so I said like, oh, if I want to find the susceptibility, so the susceptibility is like dh of M. I can write M with the critical exponent of H, and then switch back to M, and then switch back to T, and like play with that to instead of like do the long calculation. So if you do that here, so I'm using the second critical exponent. So we say, oh, the susceptibility is the derivative of H1 over delta, because I know how the magnetization depends on the field. So this is going to give me something that's like H1 over delta minus 1. And now I'm going to switch back to the magnetization. So this is equal to M1 minus delta. And now if I want to write the magnetization as function of the temperature, so I'm using the first one. So this is going to be equal to T beta 1 minus delta, and we know that the susceptibility is T to minus gamma, so you can like basically just move it from like playing the exponent. So this is just
why we needed all these tables about homogeneous functions?
Hmm?
Why we needed all these things about homogeneous functions?
Yeah, so the reason we need like that, all of those stuff is not necessarily to find a critical exponent. This is just application that we can solve, and like, you know, there are only so many things that we can actually solve in like reasonable time, so we do that. But what you do here, like this can, from that we can get the scaling relation like we can get that, but we are not going to get the values of beta and delta and gamma. So it just depends what we're going to do. So this is like you don't need it. It's just so like it's nice to see how it's relate to what we did.
אז זה דרך שנייה לחישה או שזה...
No, this is not. Don't do that. Like if okay, if they ask you to like in the test to use like scaling, so you use scaling. If they find it if they ask you to find a critical exponent, you can do something like that as like a short. But this is just what we did last.
יש לי שאלה. לגבי החלק של המעבר מ-n בחזקת 1 פחות דלתה ל-t בחזקת בטא כפול 1 פחות דלתה. איך את זה רק ידענו את המעבר הזה?
Which one? The last
המעבר
one?
אחד לפני אחרון. אחד.
This one?
כן.
So I use that.
אוקיי.
Okay, so that was the tutorial. It was a very short tutorial. We don't have a lot of stuff to say about scaling, so.
אתה רוצה לצלם את זה? בשיעורי בית האחרון, התרגיל האחרון שנתת, שתי שאלות בעצם. אחד, שלפעמים אתם מסמנים